Deepfakes just got harder to detect. Quantum computing in Canada takes a big step forward. Rumors that Google's Gemini could be integrated into Siri and running AI on your smartphone? It's possible. Welcome to Hashtag Trending. I'm your host, Dr. Hema Murthy, sitting in for Jim Love. Deepfakes, the ability of AI to create incredibly realistic voice and even video impersonations of real people, have exploded into our online lives. And while some use these for fun and satire, there's a darker side to how they can be weaponized and used for fraud and impersonation scams. So, there has been a huge effort in place in trying to be able to detect and recognize deepfakes. One promising technology that was developed uses biological signals that can actually be detected even in a video, like a person's heartbeat, by observing small color changes in a person's skin. But recent advances in deepfake technology are able to defeat even these sophisticated tools. Now, there are AI models which simulate biological signals, including heartbeats, in synthetic videos. This means that the current deepfake detectors, which use physiological clues, are now less effective, making it once again harder to trust video content, even with advanced forensic analysis. This has led to a resurgence in interest in digital watermarking and provenance tracking, which includes metadata to track the transformation of a piece of data. And researchers are also exploring new methods, such as multimodal detection, which combines audio, video, and contextual clues. As detection tools get smarter, so do the creators of deepfakes as a new technological arms race continues. A Canadian startup based in Quebec, Nord Quantique claims to have made a significant breakthrough in solving one major challenge in quantum computing. While quantum processors offer an almost magical promise, they have one fundamental flaw. The quantum states are fragile, and even the most infinitesimally small disruption creates errors in the calculation. So, they require enormous amounts of equipment and space dedicated to shielding the fragile qubits and taking them down to near absolute zero temperatures. Still, the errors persist, and for every qubit that is used in calculation, many more are used to cope with the quantum error correction and checks for the integrity of the quantum data. This is currently the central obstacle in quantum computing. So by improving error correction, we could get closer to building fault-tolerant utility-scale quantum computers. Nord Quantique claims that it has found a way to make massive improvements to this process and projects that we could see this in real-world use by as early as 2029. I'm not a quantum physicist, but according to a story in the Globe and Mail, what's different about Nord Quantique's work is that the hardware doing the checking is the same hardware doing the calculating, which is different from the work at Google, Microsoft, and Amazon. The experimental results suggest that larger commercially relevant quantum computers can be constructed from similar components. If so, those computers might occupy only a modest amount of space, something that would fit inside a standard data center, rather than a football field-sized complex that some fear will be required to get other types of quantum systems to run reliably. It also uses much less energy. Nord Quantique and other organizations in Quebec have received funding from both the Canadian and the provincial Quebec government to accelerate quantum technology development, adoption, and commercialization. There have been many claims to breakthroughs in quantum computing. Many of them are later found to be less impressive than their original announcement. But there are some signs that Nord Quantique could be moving in the right direction. DARPA, the U.S. Defense Advanced Research Projects Agency, has initiated a quantum benchmarking initiative in which Nord Quantique was selected to participate. The goal of this initiative is to have an effective quantum computer by 2033. And Nord Quantique is not the only Canadian company showing promising results in this area. Other Canadian facilities that are participating in this benchmarking initiative are Xanadu from Toronto and Photonic from Vancouver. The Toronto Waterloo Innovation Corridor in Ontario is known to have the highest amount of quantum research and deemed the most significant quantum cluster. Calgary, Alberta, and then the Vancouver area, British Columbia, both have research centers which are strong in different areas of quantum research and hardware development, making Canada one of the world's largest countries in quantum computing research and one of the leaders with a national quantum strategy. In the area of AI research, Canadian research played a huge role in developing what we know of as generative AI, and is one reason why Canadian Geoffrey Hinton shared a Nobel Prize recently. It could be that history may repeat itself this time in the area of quantum computing. Apple, long regarded as a leader in user experience, has certainly fallen behind with its voice assistant. Siri is a pale comparison to other intelligent voice systems from OpenAI, Google, and others. Even Amazon's Alexa is reported to be having a huge upgrade. But there are rumors that Siri could finally move beyond basic commands from an unlikely source, the integration of Google's Gemini. Google's Gemini has made huge progress in the past months, and now it could make Siri more competitive than other voice assistants. It could not only be far more responsive and able to have more real conversations, but it could also be much more usable, as it would have access to all of Google's AI capabilities in search and knowledge retrieval. Integration with Gmail, Calendar, and Photos from Google Photos could enable Siri to assist with reminders for meetings, events, and even photo memories. Reportedly, these integrations would be opt-in, transparent, and under user control, according to both Apple and Google. But the privacy issue may be a huge one for Apple that has built a reputation on protecting user data. With the integration of a third-party AI model into Apple's traditionally closed ecosystem, keeping data protected could be a challenge for Apple. But rival Samsung already integrates Gemini in its devices, creating competitive pressure for Apple to include a better AI assistant to stay relevant. In the big announcements that surround Google's I/O conference, one significant item seems to have flown under the radar. Google has launched a new app called Google AI Edge Gallery that allows users to download and run AI models locally on their smartphones without an internet connection. Currently limited to Android devices, this app allows users to browse, download, and run a variety of openly available AI models without connecting to the cloud. Cloud-based AI computing leaves users wary of sending personal or sensitive data to a remote data server. Even though these are not the large AI models, they are incredibly powerful. Despite their size, there will be issues with device hardware limitations. But new phones also have increased processing power. While not matching the full power of the cloud-based AI model, the local model will allow for use where the internet may not be available, for example, making it accessible to larger populations in remote areas as well. Currently available only on Android with a download from GitHub, Play Store availability, and an iOS version is in development. And that's our show. We would like to hear your comment. You can reach us at editorial@technewsday.ca. I'm your host, Dr. Hema Murthy. Jim will be back on Tuesday morning. Have a fun day.